Hello students and short questions from GATE 2015. The first question from Formation and Power in short question category, that is 1 marks or 2 marks. A power operated chap cutter with two knives is rotating at 600 rpm. It has a conveyor type feeding mechanism which operates at a speed of 0.6 meter per second. The theoretical chap length in millimeter is 20 millimeter, 30 millimeter, 60 millimeter, 90 millimeter. It's a very straightforward and easy question. Basically, the feeding mechanism speed is given 0.6 meter per second, and number of knives are 2, and rotation of speed is 600 rpm. Therefore, the chap length will be the speed divided by number of knives and rpm of the chap cutter. Since the rpm is given in rotation per minute, so 60 has to multiply, and meter is given the feeding mechanism speed. You have to find out millimeter per second, millimeter in the length. That's why 60 into 1000 for millimeter, from converting from meter to millimeter. Number of knives and rpm of chap cutter, it's very simple. So multiply with the chap length will be 60 into 1000 into 0.6 is the speed, divided into is the number of knives, rpm of the chap cutter, 600. The answer will be 30 millimeter. So this is the answer for the first question. Next question is the conversion efficiency of a solar cell is 12%. For a maximum power output of 9 into 10 to the power minus 3 watt at an incident solar radiation of 250 watt per meter square. The required surface area of the solar cell in millimeter square will be dash. So we know power output is equal to incident solar radiation. How much solar radiation is incident that falling on the surface area of the solar cell? So that means area into the incident solar radiation into conversion efficiency. How much is converted into the power? Basically 12%, 12 to 16% is the conversion efficiency of solar cell, divided 100, because the conversion efficiency is given in percentage. To make it a fraction, you have to multiply, divide 100. That's why it's very easy. Power output is given 90 to 10 to the minus 3 watt per meter, watt. 250 is the incident solar radiation, watt per meter square, and area you have to calculate in millimeter square. 10 to the minus 6 is for meter to millimeter, so here actually meter square is given, watt per meter square. To cancel it out, so minus 6 you have to multiply millimeter to meter, into 12 is the conversion efficiency divided 100. Therefore, the area of the solar cell will be 300 millimeter square. Therefore, answer is 300. Next question: the brake power of a 6-cylinder first-stroke diesel engine running at 3000 rpm is 125 kilowatt. Its brake specific fuel consumption is 200 gram per kilowatt per hour. Assuming specific gravity of fuel is 0.85, the volume of fuel to be injected per cycle per cylinder in milliliter is how much? Basically, the fuel injected in milliliter per hour is, because it is given in gram per kilowatt per hour, you have to convert it into milliliter, because it is asked, the answer is to be in milliliter. That's why the brake specific fuel consumption, BSFC, in gram per kilowatt per hour into brake power, it's given 125 kilowatt. So specific gravity you have to convert, because 1 ml is equivalent to 0.85 gram. Therefore, from gram to liter you have to divide it. If the vice versa, you have to multiply it. Therefore, the fuel injected in milliliter per hour will be 200 into 125, that is the BP brake power, divided 0.85, that is 29,411.76 ml per hour. You have to inject the fuel into 6 cylinders, and at the same time 3000 rpm is there. Means there will be 3000 rotation, that means cycle will be 3000 divided 2. Therefore, the fuel injected per cycle per cylinder will be equal to fuel injected per hour. Already we calculated, that is 29,411.76 ml. Therefore, you you can easily calculate fuel injected per hour divided number of cylinder, because it is asked per cylinder, it is asked, and per cycle, because you know each cycle has two revolution. That's why 3000 rpm is given, so you have to divide it by 2. And since we have calculated the fuel injected in liter per hour, here actually the rpm is per minute, so you have to multiply to make it per hour, number of cycles per hour. That's why 60 is multiplied. Straightforward, putting the values, that is 29,411.76 ml calculated per hour divided by 6 number of cylinder, 3000 is the rpm, 60 by 2, it will be 0.0545 ml is the answer. Therefore, the answer is the volume injected per cycle per cylinder is 0.0545 milliliter. Next question. For a reference sound pressure of 2 into 10 to the power minus 5 Newton per meter square, the sound level measured at the operator's workspace of a tractor was 80 decibel. If the RMS sound pressure is increased by 8 times, the resulting sound pressure level in decibel will be dash. So we know this is a very simple problem. The decibel pressure level, or SPL, the sound pressure level, is equal to 20 logarithmic 10 P, there is the sound pressure, divided by reference sound pressure P0. This is the simple formula. Here actually 80 is given, the in decibels SPL is given 80 decibel, and the sound pressure level is given 2 into 10 to the power minus 5. Putting these values, we can calculate the sound pressure level P. Sound pressure is P, that is 2 into 10 to the power minus 5 until log 80 by 2, so that is 0.2 Newton per meter square. Now it is asked, if the RMS sound pressure is increased by 8 times, that means it increased 8 times, so that will be 0.2 into 8, 1.6 Newton per meter square. So putting this value into the new SPL, that is the sound pressure level in decibel, will be 20 log 1.6 divided 2 into 10 to the minus 5. This will, the answer will be 98.06 decibel. Therefore, the answer is 98.06. Next question. The connecting rod of an internal combustion engine is subjected to compression only, tension only, both compression and tension, or torsion. Here actually, if you see in the reciprocating motion, so when there will be compression stroke, the connecting rod will be compression, because it will try to move against its will. So compression will be there. At the same time, when there will be suction stroke or exhaust power stroke, during the suction stroke especially, there will be that means it will try to move in such a way that there will be tension will be there. Therefore, the answer will be both compression and tension is always subjected by the connecting rod. Next question. The horizontal component of soil forces acting on the front gang of a right hand offset disc harrow in the direction parallel and perpendicular to the direction of motion are 8 kN and 3 kN respectively. Corresponding forces on the rear gang are 6 kN and 7 kN respectively. If the horizontal component of pull acts toward the left of the direction of motion, its magnitude in kilonewton will be dash. Basically, this is a right-handed offset disc harrow. This is the disc harrow, offset disc harrow, and this is right-handed. So it will tilt to right side of the tractor. If you say this is the motion of the tractor. So it is asked that the front gang is having horizontal components of parallel and perpendicular direction motion are 8 kN and 3 kN. Latest, this is the force for the front gang, that is the horizontal force parallel to the direction of motion, that is 8 kN. and also a perpendicular force is 3 kilonewton. That is, these are the forces acting on the front gang. Similarly, the forces acting on the rear gang will be uh, parallel force is 6 kilonewton and the perpendicular is 7 kilonewton. So the direction of perpendicular forces will be just opposite if you see, because the soil will be flowing towards right in the case of front gang and towards left in case of right sorry rear gang. Therefore, the forces, side forces will act just opposite. Therefore, the resultant forces, now we will calculate the resultant force here. Actually the parallel resultant from the two front gang and rear gang will be equal to 8 plus 6, because they are in opposite same direction. That's why the vector quantity will be summed up. So this 8 plus 6 is 14 kilonewton for the parallel force. Similarly, if you see the perpendicular force, that they are already front gang and rear gang, they are opposite to each other, so they are cancelled each other. So therefore the resultant perpendicular force will be 7 is the rear gang and 3 is the front gang. The resultant will be 7 minus 3, that is 4 kilonewton, because they are opposite to each other. Therefore they are cancelling out, so 4 kilonewton. Now the resultant is right side of the offset disk arrow. Therefore the resultant will be, they are perpendicular to each other. Therefore the answer will be 14 square plus 4 square, that is 14.56 kilonewton is the resultant horizontal component of all the forces from the front and rear. Therefore the answer is 14.56. Next, a two-wheel drive tractor is operating a moldwood plow at an average speed of 4 km per hour. The draft and the rear axle torque are found to be 30 kN and 25 kN into meter respectively. If the rolling radius of traction wheel is 0.7 meter and the wheel slip is 20%, the tractive efficiency in percent will be 67.19, 46.71, 72.87, 84. Basically, it's a very simple question. Here actually the let us have the rear wheel or rear axle. Here actually it is saying it is moving at a 4 km per hour. Here actually we don't use the average speed. It is given 4 km per hour. We will not use. Therefore, the rolling radius is given. We know in this case the torque is given, axle torque is given and rolling radius is given. We know rear axle torque or TR in kilonewton into meter is equal to net tractive force, that is F into rolling radius. So rolling radius is given here, that is 0.7 meter, and net tractive force, that is F, we have to find out. So that's why 25 is given, that is torque, and F is the net tractive force into rolling radius. From here we can find out the net tractive force. F is 35.72 kilonewton. So this is the net tractive force, that is 35.72 kilonewton. Now actual speed is given, that is 4 km per hour. We know actual speed is equal to theoretical speed into 1 minus s, where s is the slip. Slip is given 20% here. If you see 20% slip is given, therefore s is in fraction, so s will be 0.2. So this is forward speed. Therefore the theoretical speed will be let it Vt, that is Va by 1 by 0.2, because it's a 20% slip is given. Therefore the velocity, theoretical velocity is 1.25 into actual velocity. Now tractive efficiency we know, that is drawbar power divided by wheel power. So in this case drawbar power is equal to draft, that is H is given 30 kilonewton. Therefore 13 kilonewton into actual velocity, which is given 4 km per hour, which we will not use for numerical value. But if you see the wheel power, that is net tractive force into theoretical velocity. and already you calculate theoretical velocity is equal to 1.25 va, so we just directly put it here and they will cancel each other. Therefore we put tractive efficiency is equal to 30 is the draft into va is the actual velocity divided by 35.72 is the net tractive force into 1.25 va is the theoretical velocity. Therefore va cancelled out. Here actually you will notice that 4 km per hour we don't use, since it will be cancelling each other. Therefore 30 divided this much will be into 100. For the tractive efficiency in percentage, it will be 67.19%. Therefore the answer is 67.